Hello everyone, welcome to MathsTuber. So this is the second part of the video that we have created about logarithm. So today we are going to learn about how to see the log table and how to solve the questions and the applications related to it. So logarithm and anti-logarithm. So before coming to the topic, we have to first see how to convert a number into standard form. So suppose you have a number 175,000. Now if you want to convert it into standard form, we have to place the decimal after one non-zero number. That is 1 is the first non-zero number, so 1.75. And then you have to count all the digits after this 1. That will become the power of 10 here. So there are 6 digits after 1, so 10 raised to power 6 will be here. Similarly, if you have 316052, suppose this is the number, then it will be 3.16052, and you can see there are 5 digits after 3. And similarly 7560000, so you can write it as 7.56 into 10 raised to power 6, 110500000. So you can write it as 1.105 into 10 raised to power 8, right? Because we are shifting the decimal from the right hand side to the left hand side. So the power becomes positive here, right? Now, if a number is there in which we already have a decimal, suppose we have 0.0000567. So what we have to do here is we have to shift this decimal after the first non-zero place, non-zero number. So for 5 is the first non-zero number, so it will be shifted here. And you have to count, because we are shifting the decimal to the right hand side, so the power will be negative, the power of 10 will be negative, and it will be equal to the number of digits in between the two places where the decimals are. So there are 5 digits between the older place and the newer place of the decimal, so it will be 10 raised to power minus 5. Suppose you have 0.0526. So we want to shift this decimal after this 5. So it will be 5.26 into 10 raised to power minus 2, because there are 2 decimal places between the newer and the older place of the decimal. And if you have 0.000897, so 8.97 into 10 raised to power minus of, we have to shift it from here to here, so it will be minus 4, because there are 4 places between the decimal, right? So this is how we have to convert a larger number and a smaller number into the standard form. And based on this standard form, we are going to see the logarithmic table. So first of all, let us have a look at what is characteristic and mantissa. There are two parts in a log, in a number. One is characteristic and another is mantissa. Suppose x is a number which is written as m into 10 raised to power p, right? There is some power p here, and m is the number which we have to find out. So to find out the log, we have to take log both the sides. So it will be log of m into 10 raised to power p. And according to the law of logarithm, we can write it as log m plus log of 10 raised to power p. Now this log m will be written as it is, and this power will come in front here, and this will become log 10. And we know that log 10 is always 1, so it will be p. So the power of 10 becomes the characteristic here. This is the characteristic. And this log m becomes the mantissa here. Right, so we have to find out the value of this log m, and that becomes the mantissa, and the power of 10 becomes the characteristic. Right, so we can directly write down the power here as characteristic and log m as mantissa. Now let's move to some of the examples. So let's start with a simple example. Suppose log 2 we have, because it is already converted into the standard form. 2 can also be written as 2 into 10 raised to power 0, and the characteristic becomes 0, and this will become log 2. So you just have to find out the value of log 2 here. And how to find out the value of log 2? 2 can be written as 2.000, right? So now in the log table, you have to find the place 2.0. So we have the log table here. So you can see that you have to find out log of 20 here, because 2.0 becomes 20. And because the next number is also 0, so you have to see the 0th column. So the answer is 3010, right? And then this is the mean difference, where we have to see the 0th column again, but there is no 0th column here. So we will go with 3010 only. So the value will be, we have to write it like this: 0 plus 0.3010. The number there, 3010, we have to put point before writing that number. So the answer will be 0.3010. Right, so this is how we have to see the log table. Now the second example is, suppose we want to find out the log of 59. So log of, we have to convert it into standard form first. It can be written as 5.9 into 10 raised to power 1. So basically, if we just simplify it, characteristic becomes 1, and you have to find out the log of 5.9 here. So 1 plus, now log of 5.9, you have to find out 59 in this table. So you can find 59 here, and you have to see it on the 0th column only, because there is no number after 5.9, so it will be a 0. So it will be 7709. So you have to write it in decimal places, 0.7709. So 1 plus 0.7709, it becomes 1 plus 1.7709, and this will be the answer, right? Similarly, we can have another example. Suppose you want to find out the value of 289. So first of all, you have to convert it into standard form. So it will be 2.89 into 10 raised to power 2. Now the characteristic becomes 2, as it is the power of 2. So we can write it here, and we have to find the value of 2.89. So what we have to do is, we have to find the log of 28 at the 9th position, right? So first of all, find out 28 here, which is here, and at the 9th column, because we have 2.89. So this is the value 4609. And after that, there is no number, so we don't have to go to the mean difference. So 4609 we have to write here. So it will be 2 plus 0.4609. So it will be 2.4609 will be your answer, right? Now the next one is, suppose we have four numbers here, 1743. Suppose this is the number. We have to first convert it into standard form, that is 1.743 into 10 raised to power 3. So this 3 becomes the characteristic now, and log of 1.743 is the mantissa that we have to find out. So log of 1.743 means you have to find 17 first in the log table. Then you have to find the fourth column, the value on the fourth column, and then third row in the third column in the mean difference also that we have to add. So that was 17.43. So first find out 17. This is 17. Then on the fourth column, its value is 2405. And on the third column of the mean difference, it is 7. So we have to first add both of these, 2405 plus 7. If we add this, you will get 2412, and we have to write it here like 3 plus 0.2412, which means 3.2412. So this is how we have to find the values of logs on the log table, right? So you just have to we can only find the values till the three terms after this decimal place. After that we cannot find it, so we will always have, if we have greater number than that, then we have to avoid that last digits after the three digits of decimals. So next question is, suppose we have now we have the logs of 0.009. Suppose we have this, we have to first convert it into standard form. See, we can write it as 9 into 10 raised to power 3. So basically minus 3 becomes the characteristic here, but we have to write it 3 bar. We do not write minus 3 as the characteristic. Instead of this minus 3, we write it as 3 bar plus log 9 we have to find out at the 0th column. So log 9 is, you can see here, log 9, 9 is actually 90 because 9.0 we have to take. So you have to find out the value of 9.0 at 0th column, which is 9542, right? So 9542 we have to write it in decimal form, 0.9542, and it becomes 3 bar 0.9542. This will be the answer. Similarly, if you have a greater number, suppose 0.0000752, suppose this is the number. First of all, convert this number into standard form, that is 7.52 into 10 raised to power, how much it will be? Minus 6. So if minus 6 is the power of 10, then 6 bar becomes the characteristic, and now you have to find out 7.52 here, which means 75 at second column. So you have to first find out 75 here. So 75, and second column is this one. So 8762 is the value at the second column of 75. So 0.8762 will be the 0.6782. So it will be 6 bar 0.6782 will be your answer, right? So this is how we can go for the log tables. Now let's talk about anti-logs. Suppose you have taken the log of some number and you got the value of log x as so let us take a question and try to understand anti-logarithms. So basically the procedure is the same. Suppose log x is equal to, we have a number for log x. Suppose we have log x equal to 2.1647. Suppose this is the number. So what we have to do is we have to find out the value of x from here because that's the original number. And to remove this log from here, we have to take the anti-log both the sides. So if we take the anti-log, log will be removed from here and we have to find out the anti-log of 2.1647, right? Now this 2 becomes uh, this 2 becomes the power of 2 basically, which was the characteristic in case of the logarithms. So we have to basically find out the answer for 1647, right? So basically it will be anti-log of 0.1647 into 10 raised to power 2 because this will become the power of 2 here. Now the anti-log of 0.1647, so you have to first find out 0.16 in the anti-log table. So this is the anti-log table. We have to first find out 0.16 here, which is this one. Then after that we have 47. So on the fourth column of this, we have to see. So the fourth column here is this one, and the value is 1.459. 1.459. And then at the last we have the number 7. So 7 is for this mean difference. So it is 1, 2, 3, 4, 5, 6, 7. So on the 7th column, you have the value 2 here. So you have to add it to it. So it will be added to this number, which is 1, 6, 4, and 1.461. So you have to write now 1.461 into 10 raised to power 2, which means 100. So 1461 upon 1000 into 100. So double zero gets cancelled and you will get 146.1 as the answer. Right. So basically, the procedure of anti-log is to find out the uh, is to remove the log from the given number. Now again, let us take another example. Suppose log x is given to you as 3 bar 0.4856, right? So this 3 bar is actually the characteristic of the logarithm of the number which was given to you. So if we take the anti-log both the side, it will become anti-log of 0.4856 into 10 raised to power minus 3. right? So because 3 bar can be written as 10 raised to power minus 3, and we have to find the antilog of 0.48 at the fifth column and mean difference at the sixth column. So first of all, we will find out 0.48 here. Here we have 0.48, and this is the fifth column, 3.055. And then after that, we want to find out at the sixth column, we want the mean difference, which is this 4. So we have to add 4 to it. So it will be 3.059. So the answer will be 3.059 into 10 raised to power minus 3. Or we can write it as 3. Just a second. This will be written as 3059 upon 1000 into 10 raised to power 3 can be written as 1 upon 1000. So it will be 3059 upon 1,000,000,000. So the decimal will be there before the 6 places. We already have 4 digits here, and to make it 6 digit, we have to put 2 zeros in front of 3, and then the decimal place will be here. So 0.003059 will be your answer, right? So this is how we have to find out the log and anti-log for a number. Then after that, we have another type of question. Suppose you are given with a number, let x is equal to 0.009 raised to power 1 by 3, and you want to find its value. So first of all, to remove this power, we have to take log both the sides. So log x will be equal to 1 by 3 log of 0.009, and this will be converted into standard form. So it will be log of 9 into 10 raised to power minus 3, right? So 1 by 3, 3 bar plus log of 9. Now you have to find the value of log 9 for 0th column. So let us find out log 90 for 0th column here. Log 90 for 0th column is 9542. So it will be 0.9542, and this will come out to be 1 by 3 3 bar 0.9542, right? So this is how we have done it. Now if we just divide both the numbers, or if we don't convert it into this number, we just divide 3 with both of these, then we will be getting here minus 3 plus 0.9542, and if we divide both of these numbers with 3, you will get minus 1 plus you will get 0.3187, right? So this is the value of log x. Now if you want to find out uh, the value of x here, so you have to take the anti-log for that. So therefore x will be equal to the anti-log of 1 bar 0.3187, which means anti-log of 0.3187 into 10 raised to power minus 1. So try to find out the antilog of 0.3187 here. So if we see here 0.31 on the antilog table, 0.31, then we have to find its 8th column, which is this one, 2.08, and then 7th column on this table, mean difference table, which is 3. So we will add this, so it will be 2.11. So we just have to add these numbers. What we got here, 2.11 into 10 raised to power minus 1, which means 2.11 into 1 by 10, and it can be written as 0.211 will be your answer, right? Then after that, let's come to the applications of log and anti-log now. So the application of these log and anti-log involves a few types of questions, such as the calculation of the compound interest for more than you can say 10 years or 5 years, which cannot be solved with the normal formula. So for example, if you have a question, calculate the compound interest. So you have to calculate the compound interest where the principal is given 10,000 rupees and the time is given 10 years and the rate of interest is given 8% per annum, and it is compounded half yearly. Compounded half yearly. So we know the formula for the amount principal into 1 plus r upon 200 raised to power 2n, right? The rate of interest becomes half and the times becomes double in case of half yearly. So it will be 10,000 1 plus 8 upon 200 raised to power 20, because there were 10 years and we have doubled it. So it will be 10,208 raised to upon 200 raised to power 20, right? And now if we cancel it with 2 here, it will become 100 and this will become 104. So we can write it as 10,000 into 1.04 raised to power 20, right? And this also can be written as 10 raised to power 4 into 1.04 into 10 raised to power 20. So this is the amount now, and if we want to find its value completely, we have to take log both the sides. So log of a will be equal to log of 10 raised to power 4 into 1.04 raised to power 20. So 10 log of 10 raised to power 4 plus log of 1.04 raised to power 20. So this powers will come to the front and log 10 becomes 1 plus 20 log of 1.04. And since 1.04 is already in the standard form, so it will become log of 10 at the fourth position we have to find out. So log of 10 at the fourth column is 0.170. 0.0170. And that's why it will become, if we multiply it with 20, you will get 0.340, and the answer is 4.340 for log A. But we want the complete amount here, and the amount will be, if you want to remove this log from here, you have to take anti-log both the sides. So A will be equal to anti-log of 4.34, and the anti-log of 4.34 will be anti-log of 0.34 into 10 raised to power 4, right? The number before this decimal becomes the power of 10. And now we have to find out 0.34 in the anti-log table. So 0.34 here at the 0th column is 2.188. So we will write here 2.188 into 10 raised to power 4. This will be your answer. Or you can say that 21880. This will be the amount which is in rupees. Right, so the amount will be 21,880 after 10 years if compounded half yearly. And if you want to find out the compound interest, so the formula of compound interest is amount minus principal, which is 21880 minus 10,000. So it will be 11,880 rupees. And this is the compound interest for the given question, right? So this is the first application of logs and anti-logs. Now let's come to the next one. So next type of question is where we are given with the population of the world in T years. So let the population of the world in T years after 2010. T years after 2010, by the formula it is given by P equal to 4.7 into 1.02 raised to power T, right? And it is in billions. So this is the formula for the population T years after 2010. So in the first part, we have to calculate the total population of the world in the year 2029. In the year 2029, in the nearest millions, we have to find out. So basically, you can see here, after 2010 till 2029, we have 19 years to go. So P will be given by 4.7 into 1.02 raised to power 19, right? Now to solve this question, we have to take log both the sides. Log P will be equal to log of 4.7 into 1.02 raised to power 19. If we apply the laws of logarithm here, it will become log of 4.7 plus 19 will come in front and log of 1.02. Both the numbers are in standard form already, so we can directly find out the values of log here. So first of all, log of 47 at the 0th column we have to find out. So 47 is here, and at the 0th column it is 6721. So it will be 0.6721 plus 19 multiplied by here we have 1.02, which means 10th row at the second column we have to see. So here you can see 10th row is the first row, and at the second column it is 0086. So it will be 0.0086. So if we calculate this, you will get 0.6721 plus 0.00, it will be, if we multiply both of these numbers, it will become 0.1634, and after calculating it completely you will get 0.8355, right? So the value of log p becomes 0.8355, and to remove this log we have to take the anti-log both the sides. So p will be equal to the anti-log of 0.8355, and now you can see it is already in standard form because the number before this decimal place is 0, so the characteristic becomes 0. So anti-log of 0.83 at the fifth column, and the mean difference also at the fifth column. So here we don't have 0.83 values. You can see the anti-log table in the book ML Agrawal. So the answer will come out to be 6.847 billions, because the given equation was in billions. So this will be the answer, right? But we have to convert it into millions. So 6.847 billions is actually 10 raised to power 9, right? And we have to convert it into 10 raised to power 6, then it will be converted into millions. So 6847 upon 1000 into 10 raised to power 9, it will become 6847 into 10 raised to power 6, which means 6847. Instead of 10 raised to power 6, we can write down millions here. So this will be the population in millions at the year 2029, right? Next part, second part of the same question says that we have to find the year in which the population will be double of the population of 2020. So in the second part, population in 2020, double of the population of 2020 is equal to population of t year, because we don't know which year is that. So we will find out here 2 into what was the value of p which was given to you. It was 4.7 into 1.02 raised to power 10, because after 2010 there are 10 years between 2010 and 2020, and here it will become 4.7 into 1.02 raised to power t, right? So here you can see that these two will cancel out each other, and we just have to find out the values for now. And so if we take log both the sides here, you will get log of 2 into 1.02 raised to power 10 is equal to log of 1.02 raised to power t, and this can be written as log 2 plus 10 log 1.02 is equal to t into log of 1.02, and t will be equal to log 2 plus 10 into log of 1.02 upon log of 1.02. So you just have to put the values of log 2 and log 1.02 in this. So log 2 is basically log of 20 at 0th column. So it will be 1, no, not this, here. Log of 20 is 3010. So it will be written as 0.3010 plus 10 into log of 1.02. We have already found out the value, which was 0.0086. So it will be 0.0086 divided by 0.0086, and 0.3010 plus, it can be written as 0.086 upon 0.0086, and if we add these, you will get 0.83870 upon 0.0086. So basically you will get the answer as, just a second. So after calculating this, you will get the answer as 44.97, and this 44.97 becomes 45. So approximately t will be equal to 45 years, and after 2010, 45 years, if we add 45 years in 2010, then the required year will be 2055. This will be the year, right? Similarly, we have an example in which a scientist running an experiment finds that a particular bacteria uh, colony grows every year. She expects the number of cells to be given by the formula B equal to 200 under root 20 raised to power t upon 20. So this is the formula by which the number of cells are given. If the initial population, find the number of hours after which there will be 500 bacterial cells. So you are given B equal to 500 and you want to find this T. After how many minutes or how many hours you will find out that the population is 500. So if B is equal to 500, then 500 will be equal to 200 under root 20 t raised to t by 20 raised to power t by 20. So 500 upon 200, you will get zeros will be cancelled and this will be t by 20. So 5 by 2 can be written as 2.5 and 20 square root of 20 can be written as 20 raised to power 1 by 2 whole raised to power t by 20. So this can be written as 2.5 20 raised to power t by 40. Right now, if you want to find out the answer, we have to take log both the sides. So taking log, you will get log of 2.5 is equal to t upon 40 log of 20, and log of 20 can be written as 2 point log of 2 into 10 raised to power 1. And the characteristic becomes 1 here, and this will be log 2. So you just have to find out log 2.5 and log 2 here, and then you will find the answer. So let us find out log 2.5 here. So log of 2.5 is 25 at 0th column, which is 3979. So it will be 0.3979 is equal to t upon 40, 1 plus log 2. Now log 2 is log 20 actually at the 0th column. So log 20 at 0th column is 3010. So 0.3010. Now to find out this, 0.3979 into 40 is equal to t into 1.3010. And if we multiply these, you will get the answer as, after multiplying all of these, t will be equal to 52 point, sorry, it will be 52.89. 52.89. So approximately after 53 hours, you will get the population of bacterial cells as 500. So therefore, after 53 hours, the bacteria cells will be 500. So this is how we have to solve it. And similarly, there is one more question which is based on the amplitude of the Richter scale. So the Richter scale formula is given by R equal to log of lambda upon lambda naught with base 10. So lambda is actually the measure of the earthquake wave amplitude, and lambda naught is the measure of the standard wave. And it is given in the question that there was an earthquake with a wave amplitude 2020 2020 times the standard wave, which means lambda is equal to 2020 of lambda naught, which is the 2020 times of the standard value. So lambda naught is the standard value and lambda is the value which will be given to you. And we have to find out the Richter scale value. So R will be equal to log of, we will put the value of lambda here, which is 2020 lambda naught upon lambda naught. So these two will get cancelled. And this 2020 will be converted into standard form, 2.020 into 10 raised to power 3. So you can write it as 3 plus log of 2.02. So now you have to find out the value of log of 20 at second column. So let's see the log table. Log 20 at second column is 3054. So 3054, 0.3054, which will be 3.3054. And this will be your answer. But we want to find it till the 2 decimal digits only. So it will be 3.30 only. Right? So this is how we have to do these questions. So the value of the Richter scale of the earthquake will be 3.30. So this is how we have to solve these questions.